All right, guys. So lesson 13, we are going to do a couple of sections here. So just keep in mind our pace and everything. Okay, so first we're going to start out with doing the inverse, tangent, and cotangent functions. Last time we did sine and cosine. So one of the biggest things to remember was our domain restrictions. So if you look here, and we were able to do the inverse here, we all of a sudden see that we have our asymptote still at the pi over 2 and negative pi over 2. So keep that in mind. And of course, what that means for our domain here is that we have to restrict it to those two things because we have asymptotes there. Whereas so we're going to focus on quadrant 1 and 4, just like we did with sine. Now for cotangent though, our asymptotes are at 0 and pi. So that's where we have to restrict our domain for our inverse there. So that's quadrant 1 and 2, just like cosine. I'm not going to remind you of the first quadrant of the unit circle because I think you guys should be able to do it by now. So let's go right into our examples. All right, so arctangent. So again, we are looking at the first and fourth quadrant of square root of 3. So of course, since that's positive, I know it's in the first quadrant. And remember that tangent is sine over cosine. So I want to be at the coordinate 1/2 square root of 3 over 2. And of course, where is that at? That is at pi over 3. Cotangent, remember that we're doing the first and second quadrant. It is negative, so that means we're in the second quadrant. Now, difference here is cotangent is cosine over sine, so we need the cosine to be our negative square root of 3 over 2, sine being our 1/2, and at which radian are we having that? That is 5 pi over 6. So you really need to know your unit circle. All right, now let's get into one within the other. So remember, just like we did before, let's start with the inside and then do the outside there. So cotangent, again, we are looking at the first and second quadrant. It is negative, so we're looking at the second quadrant. So what I'm going to do is say, hey, if this is theta, right, cotangent is cosine, which is -5, over sine, or we could think of it as x over y. So we get -5 over 1. Now think of this though, cotangent itself is still the x over y, which is -5. So we don't have to worry about the change there of being in a different quadrant. Okay. But here we have something else we need to look at, right? So let's look at the inside that inverse tangent. So of course we are in the first and fourth quadrant. It is negative, so we are in the fourth quadrant. So I'm going to draw my right triangle, my theta. Tangent is y over x, so -3 over, and then x is 4. So we need the hypotenuse, of course, because we're looking at sine, right? Or the radius. So if we do the Pythagorean theorem, you know, we get the value of 5 for the hypotenuse there. So that's allowing us to tell us what quadrant we're in. Now we're going to go sine in that quadrant. Well, sine is y over r, so we have -3/5. And if you want to leave yourself a note, there we go. Sine theta is -3/5. All right, let's do some algebraic expressions. So one thing I'm going to look at is, excuse me, when we do arc tangent of x, what we're doing is we're finding a theta. Oops, I should say x equals theta. That means at any time that we need the value of x, we can do x equals tangent theta. All right, so let me replace theta in for our tangent. So if we look at this, we have tangent of 2 theta. Well, of course, what we can do is use our double angle, which is 2 tangent of theta all over 1 minus tangent squared theta. And what do you know, just like I saw for up here, x equals tangent of theta. So let me substitute those in. So 2x all over 1 minus x squared. All right, so if we think of the domain of our tangent, right? Remember the values, if we go back over here. So if we look here, right, this keeps going on forever, right? Negative infinity to infinity. We just have a restriction from negative pi over 2 to pi over 2 here. So what we need to do is look at that domain. So when we think of our original tangent, we think of negative infinity to infinity. But if we look at our expression that we came into, what other values can't x be? Well, x cannot be -1 and 1, because otherwise we would have a 0 in the denominator, and we can't have that. So that means our domain for this function here was originally negative infinity to infinity, but when we broke down that expression, we know that it goes to -1, can't be -1, and it can't be 1. Okay, let's look at B, cotangent. So cotangent to x. Well, I want to draw this out because maybe it will make me look at it a little bit different. Okay, so cotangent is positive 2x, so we know we're in the first quadrant there. Cotangent is x over y, so 2x all over 1, right? Now we can use the Pythagorean theorem and find that our r is the square root of 4x squared plus 1. If you need to do that Pythagorean theorem out, go for it. Now, if I break this down, so that allowed me to find the theta, right? This equals the theta. So now if I take cosine of that theta, well, cosine is y or x over r. So you get 2x is our x value over r, which is 4x squared plus 1. Now, if we look at the domain, if you go back to the cotangent graph, again, just like the tangent, it kept going on forever. So negative infinity to infinity. Then we have to look at our expression and say, hey, is there a value this could never be? Well, we know for one thing that we don't want 0 in the denominator, and we don't want a negative value in the square root. But if you look closely, whatever value you plug in for x, we're going to square it, making it a positive number. Positive times a positive is a positive. A positive plus 1 is still a positive. So we have no problems here whatsoever. So the domain is all real numbers, or we can say negative infinity to infinity. All right, now we're going to look at secant and cosecant. All right, first let's look at our restriction, what we have to restrict our domain to. Well, because we have asymptotes in here, right? Now, secant usually is, secant is our inverse to cosine, which cosine was 0 to pi, right? But what happens between 0 and pi is that it can't be pi over 2 because we would have an undefined. That is our asymptote. So what we're going to do is you can think of it as cosine, but also keep in mind that there is an asymptote in between there, so it cannot include pi over 2. And this is what the graph looks like. As you can see, it is still a function here. Cosecant, well, let's think of that as, hey, it's a reciprocal of sine. And sine was negative pi over 2 to pi over 2 for it to still be a function. That's why we had to restrict that domain. But there is an asymptote at 0 when it comes to cosecant. So think of it like our sine, but it does not include 0 because of the asymptote. And you see that this is a function. Okay, so let's keep in mind those restrictions there. All right, arc secant. So again, I'm looking at quadrant 1 and 2, but of course I'm not including technically the pi over 2 whatsoever. And I'm looking at what I could actually value this at is change this to arc cosine of 1/2, right? Because it's just the reciprocal. And where is cosine of 1/2? Well, we're in the first quadrant. And we have 1/2 comma square root of 2, 3 over 2, which cosine equaling 1/2 is at pi over 3. Okay, so it's actually a good thing to flip it or do the reciprocal before you look at your unit circle. So here, if I flip it, I have sine of negative 1/2. Let's keep in mind that sine is first and fourth quadrant. Okay, so we're down here. So we're at square root of 3 over 2, negative 1/2. We also have to keep in mind, hey, I'm going clockwise. So it's going to be negative. It is going to be negative pi over 6. Okay, let's do this inside out, right? So the first thing I'm going to do is actually solve for secant of 5 pi over 4. So if I go to 5 pi over 4, I realize I'm at 45. So when I do this out and I do the reciprocal, I end up with negative square root of 2. Because this is in the third quadrant. Okay. Now, if I think of this as, hey, I want to rearrange this as cosine, I have to flip this, negative 1 over the square root of 2, which, by the way, is square root of 2 over 2, right? And where is cosine, this value? Well, we're only in the first and second quadrant, so we must be in the second. And where is that value? Well, that's at 3 pi over 4. So inside out, can't just cancel things. Okay, let's do arc cosecant. So this really is not on our unit circle nicely. So let's actually do what we did in sine and cosine and just give that a tangent. So, or not tangent, a theta. So I know the arc cosecant of negative 3 is some theta, which means that negative 3 equals cosecant of theta. Now, what can I do in relation to cotangent? Well, there's a Pythagorean identity there, right? So let me mark that down, Pythagorean identity. That identity is 1 plus cotangent squared theta equals cosecant squared theta. And we know cosecant. Cosecant is negative 3. So I have 1 plus cotangent squared theta equals 9. Now, of course, I'm going to subtract 1 and then take the square root, right? So right now I get cotangent of theta equals plus or minus the square root of 8. But by the way, the square root of 8 broken down is 2 square root of 2. But we need to figure out, hey, wait a second, is this going to be positive or negative? Okay. Well, first of all, if I go back and I say cosecant is in between the first and fourth quadrant, and to make it negative, it must be in the fourth quadrant. Now, so since it's in the fourth quadrant and cotangent goes from negative, let's see, what was I? Since we're in the fourth quadrant, I'm just going to say fourth quadrant. Fourth quadrant's cotangent is going to be negative. Okay, so our value is negative 2 square root of 2. So keep in mind, since we're in the fourth quadrant, we're looking at negative square root of 2 to 0. And we know for cotangent, so this is equal. Okay, so I'm just trying to look at a train of thought, guys, here. Because we were dealing with cosecant, remember that cosecant cannot be include 0, so that's why there is no equal sign under there, but it can include negative pi over 2. So this is coming from cosecant. That is where I'm looking at that restriction. I know it's in the fourth quadrant, so it must be negative for cotangent. All right, let's see if we can do some of the expressions. Okay, just like we did up here, what we're going to do is set our arc secant of x equaling theta. So that means x, sorry guys, x equals secant theta. All right, now how can I relate secant and tangent? Pythagorean identity. So we have 1 plus tangent squared theta equaling secant squared theta. So 1 plus tangent squared theta equals x squared. Let's do some solving here. Let's go all the way, and we go a tangent of theta equals plus or minus the square root of x squared minus 1. All right, so when we think of secant, we have to be arc secant, we have to be in the first 2 quadrants there, right? So it could be either one, because we don't know what x is. It could be positive, it could be negative, because we are squaring it, so we have no idea. We still come up with the same theta. So what we actually have to do for our domain on this is we actually have to say that tangent will be a positive square root of x squared minus 1 if theta is between 0 and pi over 2. Now, I do not include, even though I just did, I do not include pi over 2 for the fact that there's an asymptote there for arc secant, right? And then we have negative square root of x squared minus 2 if theta is between pi over 2 and pi. And again, not including pi over 2, because that's a restriction. So we have 2 answers for the fact that we don't know which theta is that value, okay? Some cases we do, some cases we don't. All right, let's check our B here. Let's look and set this equal. So cosecant inverse of 4x equals theta. So 4x equals cosecant of theta. This also means, because I'm dealing with cosine, so if I'm following the same pattern here, I don't want to deal with cosecant and cosine. There's nothing there that I can use an identity for going from right to the other. But I can change cosecant into the reciprocal and say, hey, this is 1 over 4x equals sine of theta. Now I have a relationship between sine and cosine by doing the Pythagorean identity of sine squared theta plus cosine squared theta equals 1. So here I get 1 over 16x squared plus cosine squared theta equals 1. Do a bunch of my algebra there. I get cosine theta equals plus or minus the square root. Now look at this. If I said 1 minus 1 over 16x squared, I can do some algebra with that and actually put it in one big fraction and then be able to manipulate the denominator. And I'm going to show you here this. So to add fractions or subtract fractions, right? I'm going to have a common denominator. So I end up with 16x squared minus 1 all over 16x squared. Now we can take the square root of 16x squared in that denominator by saying cosine theta equals the square root of 16x squared minus 1 all over 4. And then we're going to do the absolute value of x because x has to be positive, right? Or technically it could be positive or negative, but it's going to be a positive value no matter what because we're squaring it. So that's why we have the absolute value there. Now the biggest question is, hey, is this going to be positive or negative? So remember that cosecant is in the first and fourth quadrant. And in this case, it is a positive, right? So then when we do cosine, well, that automatically makes cosine a positive. Well, actually in either one, right? Cosine would be positive, so that works. Now, we need to do the domain. So let's look what happens. We have two things to think about. Well, in the denominator, can that ever be 0? Yeah, it can be 0 at 0. So be careful there. That's step 1. Step 2 is our square root. Our square root has to be a positive. So the 16x squared minus 1 has to be greater than or equal to 0. So when we solve this, I get 16x squared has to be greater than or equal to 1. And then we get x squared has to be greater than or equal to 1 over 16. Now, when we take the square root, we have to remember that it's going to be everything on the outside of it. So when I take the square root, I get x has to be greater than or equal to 1/4, or x can be less than or equal to negative 1/4. Now I don't have to include my 0 because as you can see, my 0 or exclude because it's already excluded on here. Think of this as a number line. We're going to the right of 1/4 and to the left of negative 1/4. So we're not including that 0. All right, what you guys are going to do is go on to the next video to do that last part of section 5.4, and we're done with lesson 13.